Okay, this video is for anyone who wasn't able to make it to the meet where we talked about the atomic structure notes that we're taking. First off, I want to point out that these should be in your science notebook. Your science notebook will be available to you on your tests, so it's your resource, so make sure you're taking good notes in it. One of the ways that we take good notes is we keep our table of contents up to date. So if you listen to my instructions the last time we took notes on the metric conversions notes, I gave some instructions on how to set up your notebook. So your table of contents should be your first page or two. This only has one. Ideally you would have 2 pages of table of contents, and then you would start numbering page 1 here, 2, blah 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 throughout. So 1, 2, 3, etc. I told you guys to number it up to 20. So you should, if you did that, you should already have metric conversions notes here, and then the pages that it's on, or at least the page that it starts on. And then every time we take notes, we're going to put the title of the notes in 2 places. One will be in the table of contents, and the other place is going to be on the top of whatever new blank page you're starting on. Ideally, so my last stuff ended on this page, so I'm going to start my next notes here. Today's notes are called atomic structure notes. I'm going to go through this kind of quickly in the video because you can pause me, okay? So anytime you need to pause to write stuff down, just pause the video and restart it when you're ready. So the first thing we wanted to talk about is the structure of the tiles on the periodic table. So if you've seen a periodic table before, you know, they look like this, and each tile has certain information in it. We want to copy down this tile, and we want to talk about the different parts here. So this number up top is called the atomic number. It tells us the number of protons in that in one atom of that element. So carbon is an element, so the atomic number tells us the number of protons in one atom of that element. The letter is the element symbol. It's usually 1 or 2 letters. The element name is what comes next, and finally the atomic mass is the decimal number, usually at the bottom. Not all periodic tables will have all of these things, but often they do. So get those copied down. Next thing I want to talk about is the difference, just some terms here that students often get confused. The atomic mass, so this number down here, where does that number come from? Well, it's not just a made-up number. It's actually the mass of the protons plus the mass of the neutrons plus the mass of the electrons. Now, if you need to write out protons, neutrons, and electrons, that's fine. Or maybe you could make a little note off to the side, P equals protons, N equals neutrons, etc. But this is just sort of the simplified way to do it. So the atomic mass is the mass of the protons and the neutrons and the electrons in one atom, all added together. Okay. There's a similar term called mass number. Now the mass number is just the number of protons and neutrons, not the mass of the electrons. Electrons have a really tiny mass, and so the mass number is essentially just the number of protons and neutrons. Another important distinction is that this is the mass of protons, neutrons, electrons. This is the number of protons and neutrons. Okay. Now the way we find the mass number is by rounding the atomic mass to the nearest whole number. No decimal. My handwriting I know is bad. To find, round the atomic mass to the nearest whole number. And then in parentheses, no decimal. So the atomic mass here is 12.011, which means that the mass number for carbon is 12, because 12.00 rounds down, so we keep that number the same. So 12. Now you'll notice in my notes I put these 2 things in a little squiggly box. To me, I want you to group those somehow to tell you that these ideas belong together. The atomic mass and the mass number are ideas that are related and that students often get kind of mixed up and confused. So I would group them so that they kind of stick together in your notes. Next, we need to talk about the parts of the atom. So we've got protons, which if you have colored pens or markers or whatever, I would indicate with red. If you just have a pencil, indicate it with a circle with a plus sign in the middle. What I need you to know about protons is that they are positive, they have a positive charge, and they are in the nucleus. Next, we have electrons. Again, so I have a black circle there, or you can use a circle with a negative sign, a minus sign in it. What I need you to know that electrons are negative, and they are outside of the nucleus. We'll see how that looks in a minute. And then finally, we have neutrons. Neutrons, I am using here the color blue to represent them, or just a solid filled-in pencil circle will work as well. Neutrons have no charge, and they are in the nucleus. They are neutral. Neutrons are neutral, and they are in the nucleus. Okay, so next we want to find the second half of my notes, which are right here. Next, what we want to do is draw a simple diagram of an atom. Okay, so I would just do this kind of off to one side of your page. So we've got 2 protons and 2 neutrons, however you indicated them, whether they're colors or circles or whatever. So 2 protons, 2 neutrons, and then 2 electrons. And I've got them set on a dotted line that's around the nucleus. Because remember, we said protons and neutrons are in the nucleus, and electrons are outside of the nucleus. Okay? Once you get that drawn, we need to label it. We're just going to label the stuff on the inside as the nucleus. Nucleus really just kind of means the center. So it's the core of the thing. So the nucleus is the thing in the middle. And then outside this dotted line, I want you to realize that there are 3 different names for it. I think that I tend to use energy level the most, but I want you to realize that you're going to hear this circle of dotted lines where the electrons are. You'll hear it called a number of things. Some people call it an electron shell. Some call it an electron orbital, and some call it an electron energy level. I want you to write all 3 down because I want you to realize that they all mean the same thing. I want you to know all the terms, okay? Now, once you get that written down, I separate ideas in my notes with a squiggly line. So we've sort of covered now the structure of the atom. And by the way, you don't need to have these on 2 separate pages. That's just how I filled up this page, and I moved on to the next one. So squiggly line to separate ideas. In the coming days, we're going to be drawing diagrams of atoms, and the protons and neutrons are easy. They're just always grouped together. They're just chunked together in the nucleus. But the electrons have certain rules that we need to follow so that we know where to put them in the shell or orbital energy level, whatever. So the electron energy levels have some rules. We are only going to be talking about the first 4 energy levels. Past that, it gets kind of more confusing and complex, and we don't need to know all that. So what I need you to know is that the first electron energy level can hold up to 2 electrons. So that means it can hold 1 or it can hold 2. Once we get to a 3rd electron, we need to spill over into the next energy level. That next energy level can hold up to 8 electrons. Okay? So we can have 2 in this one and up to 8 in that one. Once we fill up those first 2, we need to go to the 3rd energy level, so we're getting more energy. That one can also hold up to 8 electrons. And finally, if we fill all those up, that would be 18 electrons altogether, we need to move up to our 4th energy level, and that one holds 18 electrons altogether. So our first level can hold 2. For instance, this is the first energy level. It's the only one there, so it's the first one, and it holds 2 electrons. If we wanted to add another electron to this, we couldn't add it to this energy level. It would be full. So we would need to move on to the next energy level. Once that one fills up, we add to that. Once that one fills up, we add to that. So those are the notes for the day. The final thing that I want to show you, because these numbers are sort of weird, but I want to show you how it relates to the periodic table. So if we look at the periodic table, the horizontal rows in the periodic table are actually called periods. That's why it's a periodic table. Things repeat periodically. If we look at the first period, or the first row, you'll notice that there are 2 elements in it, just like the first energy level holds 2 electrons. Now if we look at the second row, it has 1, 2, 3, 4, 5, 6, 7, 8 elements in it. The second energy level holds 8 electrons. So everything in the first energy level, everything in the first row of the periodic table has 1 energy level. Everything in the second row has 2 energy levels. Again, that 3rd energy level held 8 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8. So we've got 1 energy level, 2 energy levels, 3 energy levels. Announcement.
Attention students and staff.
The 4th energy level is here. There's 18.
RTI. Just a reminder when you report.
Sorry, Mr. Fisher interrupted me. Anyway, like I was saying, we said that the fourth energy level holds 18 electrons. Well, there are 18 elements here in this fourth row of the periodic table. So that may have been a little bit more than you want to know. You don't necessarily, I'm just showing you why the energy levels have these funny numbers like they do. So if you've got these into your notes, you are caught up for the day. Make sure your notes are in your notebook, clear and easy to read, and don't lose that notebook, all right?